Alright, today we're going to be discussing graphing relationships. We want to take a look at this situation and then try to match it to a graph down below. So an eagle flies from the top of a tree up to his nest on a cliff, and he perches on his nest until he spots his prey. He swoops down to the ground, grabs his prey, and flies away. Alright, let's take a look at the graphs down below. So each graph has height versus time. So at the beginning of this situation, the eagle is at the top of the tree. So that would indicate that he's not on the ground. Well, here on the first graph, see how the height it starts at this point? Well, that point indicates that he's on the ground because the height would be 0. So we can't choose that graph. So we're going to cross it out. The next graph also has the same problem. See, it's saying that the eagle would have started on the ground. So we do not want that one. The other two graphs, okay, so the eagle starts maybe up in a tree. Sounds good. Okay, so the eagle flies from the top of the tree up to his nest on a cliff. So he's going to fly upwards, meaning his height should increase. On the first graph, he does fly up. On the second graph, it shows level, like he stays flat. Meaning that he's not changing his height. He's not flying up to his nest on a cliff. So I believe the graph that we have should definitely be C, but let's check the rest of the situation. So, reading again, the eagle flies from the top of a tree up to his nest. Then he perches on his nest. Perching meaning that he stays at his nest for a certain period of time, so his height does not change until he spots his prey. He swoops down to the ground and grabs his prey and then flies away. That graph is a beautiful graph for this situation. So hopefully you're able to look at graphs and determine which one would match. So let's take a look then at the possibility of what if we had wanted to create a situation for graph D in that situation. So let's kind of use the same thing about the eagle. So the eagle is not on the ground, so he must be up somewhere. So let's just say he's up, I guess, maybe on his nest. Then he's going to sit there for a while. His height does not change over the course of time. So the eagle would sit there, and then it looks like he flies down and perches somewhere else. So maybe this time he perches in the tree. And then it goes back up, so maybe he flies away. So let's write that situation. Alright, so my situation is an eagle sits on his nest, then flies down to a tree branch. He lands on the tree branch to watch for prey, and then he flies up into the air. Not super creative, but it matches the graph. Alright, so what we're looking for in our graphs is different segments and what happens with the segments. So I've drawn the different segments that we could possibly see. This segment here looks like it's going downwards as we move to the right. So I'm going to call that decreasing. Okay, and then this next segment here looks like it's going up. So we call that increasing. And this last one is going neither up nor down, so we call that constant. Now in that last situation, we didn't use decreasing, increasing, and constant to describe these segments. We used things like flies away, and goes down, and perched. So with any given situation, you're going to have to interpret the meaning of some common English words or sayings and try to decide if that fits the description of a segment that's decreasing, increasing, or constant. So what I'm going to want you to do is on your Explore sheet, numbers 1 through 6, there are some graphs for you to try and draw. Each graph is going to be based on speed and time. So for each of your graphs, you're going to need to draw a graph and on this axis we're talking speed, and on this axis we're talking time. Bring those to class, and let's see tomorrow if we agree on all of our graphs and pictures. So we will be sharing these, so make sure to draw your own pictures there. Alright, the last new concept is continuous versus discontinuous. So first off, continuous graphs are completely connected, meaning that you can draw that entire graph without ever picking up your pencil. You should be able to draw the entire graph. So all the graphs in the eagle situation, they were continuous because I could trace them with my pencil and never have to pick my pencil up. A discontinuous graph, those are not completely connected. You would have to pick up your pencil in order to draw the different parts of the graph. So far, we haven't seen any of those situations. So real quick, I'm going to draw you an example. So if I have a graph that looks like this, there's no way that I could draw that without picking up my pencil. I would trace the first segment, and then I would have to pick up my pencil and trace the second segment. So it's discontinuous. Another example of something that's discontinuous is something that's just a bunch of dots on a graph. So we need to make sure that we can recognize a situation as well as a graph. So down below here, there are some situations. For instance, the temperature in the school building for a... Alright, sorry about that. My computer kind of keyed up. Alright, so the temperature in the school building for the day. So it was probably not super cold. I doubt that it was 0 degrees. And it probably wasn't super hot either, like, say 100 degrees. So it should have been, fairly comfortable, so maybe we start there. Now, my temperature in the school building we would hope would be constant as the day progressed, but that's not always the case. The air conditioner comes on and the air conditioner turns off, so maybe it does something like this kind of all day. But never during the day does all of a sudden your temperature go from here to here, right? It never jumps. It's always changing ever so slightly, so you never notice really the difference. So I would say that this one is continuous. Alright, the height above the ground for an airplane. Well, can an airplane go from the ground and jump, say, 100 feet in the air? It doesn't do that. It takes off, and as it takes off, its height climbs. So again, a continuous situation. And finally, the time spent studying each night this week. Well, say on Monday, you study for no time on Monday. On Tuesday, you're going to study for maybe 1 hour. And then on Wednesday, you might study for 2, and then on Thursday, you don't study, and Friday, you don't study, right? Well, this is definitely discontinuous, or discrete. That's another word for discontinuous. It's because we don't study all the time. So we only have one amount of time that we studied on Monday night, one amount of time we studied on Tuesday night. And so this graph is quite jumpy. It's just a series of dots. And so that is a discrete or discontinuous situation. The word I believe that you need to know for our test is discrete. So, discrete. So we'll change discontinuous to discrete.